To summarize, the steps to be followed in performing a dimensional analysis using the method of repeating variable are as follows. Step number 1, list all the variables that are involved in the problem. Step number 2, express each of the variables in terms of basic dimension. Step number 3, determine the required numbers of pi item. And number 4, select a number of repeating variable where the number required is equal to the number of reference dimension, usually the same as the number of basic dimensions. Step 5, form the pi term by multiplying one of the non-repeating variable by the product of repeating variable each raised to an exponent that will make the combination dimensionless. Step number 6, repeat step 5 for each of the remaining non-repeating variable. Step number 7, check all the resulting pi terms to make sure they are dimensionless. And the final step is express the final form as a relationship among the pi terms and think about what it means. Selection of variable. One of the most important and difficult steps is applying dimensional analysis to any given problem is the selection of the variable that are involved. For most engineering problems, including areas outside fluid mechanics, pertinent variable can be classified into 3 groups, which is the geometry, the material properties, and the external effect. So now I would like to introduce you each groups. So the first group is about the geometry. The geometry characteristics can usually be described by a series of length and angle. So the only parameter that can be grouped as geometry is length. So the symbol is capital L. The second one is the material properties. So in some textbook, they will say that this second group is called as a kinematic group. So in kinematic groups, more relates to the kinematic property of fluid. So the simple example of the kinematic is something that telling us about how that fluid move in the system. So that's why we take velocity as the common example of kinematic parameter. So another example of example for parameter in kinematic groups is velocity, and it is acceleration and gravity, and sometimes the flow rate, because the flow rate, the unit is meter cube per second. So it's showing that how many meter cubes being flowing at one single second. So and then group number 3 is the external effect or the dynamic group. This terminology is used to denote any variable that produce or tend to produce a change in the system. For fluid mechanics, variable in this class would be related to pressure, velocity or gravity, combination of geometry and material properties. So the common example for the dynamic group is force. So this is the MLT for force, which is M, L, and T negative 2. So to make sure that you could solve this problem easily, so please look into this table, and then please remember these types of dimensionless group, because sometimes you need to use these dimensionless parameter to solve the problem. Each parameter will have their own meaning. So for example, the most common one is the Reynolds number. So the equation is rho VL over mu. So if you solve flow in pipe, so you need to use rho VD over mu. So and then this is the Reynolds number, and this is the type of application. So it is generally of importance in all type of fluid mechanics, fluid dynamic problems. So another example of dimensionless parameter is a Froude number. So usually it used in free surface and so on and so forth. So this is the idea how to choose the dimensionless parameter. In fluid mechanics 1, normally we are focusing on Reynolds number, and then but in fluid mechanics 2, so we will use Mach number sometime, and we use a Froude number in certain problems involving the free surface or open channel flow. So and then after we do the dimensionless analysis, so we could get a lot of function. So and then from that function we could solve engineering problem by using the idea of modeling and similitude. So models are widely used in fluid mechanics. Major engineering project involving structure, aircraft, ships, river, harbor, and so on frequently involve the use of model. A model of engineering model. A model is a representation of a physical system that may be used to predict the behavior of the system in some desired respect. The physical system for which the predictions are to be made is called the prototype. Usually, a model is smaller than the prototype. Therefore, it is more easily handled in the laboratory and less expensive to construct and operate than a large prototype. However, if the prototype is very small, it may be advantageous to have a model that is larger than a prototype so that it can be more easily studied. We show you a lot of parameter here with its MLT system. So I hope you could take note all these parameter and make sure you could write all the MLT system for each parameter list here. So for example, the density here is kilogram per meter cube. So and then you could write as m, l, and -3. So another parameter is listed here. So we have momentum, power, pressure, and so on and so forth. So please take a look for this table and make sure that you could list the MLT system for all the parameter given in the exam.